Hi everyone. It's really great to be here. It's pretty awesome to see. I first talked about token engineering on stage here at ETHCC 5 years ago, and it's just incredible to see how it's grown. And I have to, credit goes to so many people, and Angela and all the tireless work she's done, and the whole TEA community, and Patty and Griff and so many other people. So really, really kudos to all of you who have helped to make token engineering what it is today. And we're still at the beginning, right? Token engineering is well on its path to becoming an engineering discipline, and it's things like this event today that are really helping to drive it forward, as well as all the awesome online stuff. So really, it's my pleasure to be here today to talk about, in this case, I'm talking twice, as Angela mentioned. This talk is a story, a use case, a case study story of a token, in this case the Ocean token, and the evolution of the Ocean token in the context of the Ocean project, which we've been working on since late 2016, early 2017, so about 6 years. And I'm gonna talk about the warts and the ways that we had to address them and iterate through. And it's a lot more than I could cover in 45 minutes, so I'm gonna have to condense some things, but happy to share the journey and the learnings along the way. So with this, a quick overview of what I'll talk about. Token engineering in the core of the Ocean product, from everything before our V1, then going through our V1, our V2, our V3, our V4, and where we are now, which is post V4, and the decentralization journey. In our case, it wasn't straight out everything decentralized at once, and as well, how do you reconcile the promises of the white paper and the people who believed in it early on, compared to hitting product market fit and traction. And then besides token engineering in the core product itself, there's a bunch of token engineering around the core product that turns out to really make a big difference, and you can't ignore it. And then finally, just some other sort of grab bag of stuff. When you have a token, how do you deal with legals and token generation events and so on? And there's other talks today that go into a lot more detail, but I'll give some cursory things here. So let's get started. I will talk about, one more thing. A bit of the feel of the Ocean timeline. In 2017 was when we did the initial token design iterations. We raised seed money in the tail end that year. In 2018, we had the IEO and ICO and building. 2019, lots of building leading to our V1. 2020, we actually released our V2 and our V3, so extra busy year. That was 2020. 2021 was when the Ocean DAO first came out for grants and kept building. And then our V4 data farming. And this year, it's all about just building and growing traction, building and growing traction. And once you keep growing, you keep growing at a good exponential rate for years and years, and that's what takes you to ubiquity. And ubiquity is the name of the game for Ocean. We aim to be a public decentralized protocol across the internet. That's just there as a public good. And in the case of Ocean, it's about data access control, right? That's really the heart of Ocean. And at the higher level, it's data marketplaces and all of that. And I'm not going to talk a lot about, Ocean and the products at the higher level and stuff, except for from a token engineering perspective. For that, check out the Ocean website and all that. I really want to focus on, for you guys, teaching much more about the token mechanics and things like that. But the mission really matters, and I'll get to that. And the mission of Ocean is simply to level the playing field around data and AI. So, and that's really been a guiding thing all the way along. Okay, so the name of the game is ubiquity. So, pre-V1. So in late 2016, I published a blog post. I came from the world of AI. For 20 years, I was doing AI for chip design. And then in 2013, I jumped over to do work on blockchain, NFTs and Bitcoin and more stuff. And by 2016, 2017, late 2016, I was really missing AI. So I decided to just start doing intellectual exercises, and I wrote a blog post about how blockchains can help AI, and another blog post about how blockchains can help big data. And all roads pointed to decentralized data markets. It sort of got at the heart of this problem of how do AI researchers get their hands on more data, especially if you're not inside Google or Facebook. So that was one of the things that led me, but there was many other things around data and privacy we were seeing with social media, et cetera. So from that, we're like, okay, we're going to try to do a decentralized data market, but what does that look like? We also want to have data commons. So lots of iterations from those blog posts in early 2017, mid-2017. We also built a prototype, decentralized data market using BigChainDB. This was the project that I had been working on at the time, sort of as a company. that was basically MongoDB decentralized with Tendermint BFT. So we actually did this decentralized data market for Toyota, announced it at a big conference at the time. But that wasn't the name of the game. The name of the game was to come up with really a truly public permissionless decentralized data market. And along the way, we realized to unlock this, we really also needed access control. So we did a lot of iterations, lots of whiteboarding. This was really fun. Friends that would pass through Berlin would hang out and jam on whiteboards. So we had whiteboard after whiteboard of ideas, and kept at it. But it started to feel like, okay, when is this all going to end, right? So we started. I'm an engineer, so it's like, okay, try to get more and more systematic design. It really was a problem. The big problem was, when do we know when we're done, right? So, and then I sort of realized, wait a minute, this, where we're at actually looks a lot like what I've done before in the world of AI, specifically optimization design. And in the world of optimization design, there was sort of this heuristic on the left, which is, and it's actually lots of engineering design is like this. You formulate the problem. For optimization, this is the objectives, things you're trying to maximize, minimize. The constraints, the things that you have to meet, softly or in a hard way, and the design space. What are you wiggling? What are you moving through? What can you change? And then once you formulated that problem, written it down, you try to use something off the shelf if you can, right? Try an existing solver, and if there's something out there already, use it right away, right? I like to say 10x developers think faster, 100x developers import, right? So, so here, if you can use something off the shelf, you should. Just go and do it, right? Go and use, let's see here. There we go, it's back, great. So it's the same case for optimization design when you're building an optimizer or an AI system. Try an existing solver, right? If you have just a problem that can be solved as a linear programming problem, great, use a linear programming solver, right? If it can be solved with linear regression or a simple neural network or an SVM, go use it, right? And try one solver, but try a few, and use the one that works the best according to your criteria. And if that solves your problem, great, you're done. And there's a big, novelty is a wonderful. I love creation, I love inventing and all that. But when you add novelty, you add risk, right? I come from the world of genetic programming in AI, and for many years, genetic programming, it was very celebrated that GP could come up with novel things. And the thing is, whenever the more novel the thing is, the more risky it is. So I was helping to use GP to automatically invent analog circuits. But it would come up with circuits that an analog designer would look at, and they're like, maybe it works, but I don't want to use it because it will probably die in silicon and I'll be losing $10 million from the cost to manufacture this thing, or aerospace design or otherwise, right? So there's actually usually a trade-off of risk versus reward, right? So novelty equals risk. And in general, so while we celebrate novelty, understand that the more novel your thing is, the more risky it is. So you want to minimize novelty in practice, okay? So and that's the final step here, design new solver. So if you need, do design something new, but understand that you're adding a lot of risk and probably a lot of time, especially because it takes time to verify, okay? So, so this actually, all of this idea maps to token design. Formulate the problem, objectives, constraints, design space. Try an existing pattern, right? Maybe you can get away with an ERC20 factory, for example. Maybe you can get away with a token-created registry. And try different formulations or solvers. So this is a key thing. Sometimes you can just tweak the problem a bit, and you've got it solved. Bitcoin itself, it's actually a new approach to Byzantine fault tolerance. But it didn't fit in within the existing frameworks of Byzantine fault tolerance because all the ones up to that point had finality. They had this guarantee that you were fault tolerant. Bitcoin loosened this and said it's only probabilistic. So the academics didn't know what to do with it at first. They struggled with it for years. Now it's part of this broader framework. So in that case, Team Satoshi, had loosened the problem, right? Saying, we can have Byzantine fault tolerance without having to have finality guarantees. Instead, if you look at the last page of the Bitcoin white paper, he actually lists saying if you go for 6 blocks, you've got like a 1 in a billion chance of failure of finality. So, and that's good enough for basically all practical purposes, right? This is actually commonly the case where you can, just a heuristic in engineering, you can often loosen a problem by going statistical, right? It happens all the time, and it's just useful to understand. Instead of something where it's fully 100%, it's like, 6 sigma, like a 1 in a billion chance of failure. And by the way, this is how we got to scaling now, where it's doing the random broadcast, etc. Anyway, that's a tangent. The point is, I could map some existing ideas from optimization and other stuff to token design. And once we did this, the clouds parted. And let's see here. Okay, there we go. Oh, or not. Okay. Stayed too long on one slide, I think. I have to go faster. So as she's figuring that out, I'll just go ahead. So the next few slides, I'm just going to show how one of the things that I did. Oh, there we go. Awesome. Okay. Perfect. Yeah, that's it there. So, I mean, just to give some examples, in terms of formulating the problem, in crypto land, this was things like, first of all, who are the stakeholders? What do they want? This is a very useful exercise. So in the case of Ocean, we had data service providers, right? And they can add value because they have data and services. And what do they get in return? In this case, tokens, making money, et cetera. And we had other stakeholders, referrers, curators, verifiers, consumers, et cetera. And from that, then you can translate that into objectives and constraints, right? Specs, if you will. And so we had page after page after page of specs. But you know, if you have a huge page, like 5 pages of specs, it becomes unwieldy to deal with. You know, our brain is much better at handling 7 plus or minus 2 things in our head, right? So to drop that down into something practical, we made this table, and this table format has served us extremely well over the years. You've got basically, in this case, it's about 7 or 8 specs or objectives, right? And then the columns 1, 2, 3, 4. These are different designs. And basically, design number 1 was trying just an actor registry. In this case, it was a TCR of who's allowed to be part of this or not, right? And we knew that it wasn't enough, but we wanted to see how well it would do against the different objectives and constraints. And it failed on about 2/3 of them, as you can see, right? But that's the starting point. And then we said, okay, what about a data registry of the assets? Okay, it failed on, it did okay on some things, failed on others. What about a registry of both actors and of assets? And then what if you start to layer in curation markets? And we started to do better and better, but it still wasn't great. But this was all off-the-shelf stuff, and that was a key thing, you know? And if we had have, maybe number 3 would have solved it, great. Solve it and move on. And by the way, sometimes all you really do need is a centralized database. If that's the case, do it, right? You know, don't decentralize if the problem doesn't call for it. Okay, so I guess it skipped something. I guess we have design 5, 6, 7, and eventually we arrived at something that was check, 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 and then we knew we were done, and that was a key thing, right? In some design problems, you're done in 2 hours and you're good to go. Other design problems might take you 2 weeks, right? But don't assume that this is the final design. This is just basically saying, hey, this is the most promising thing. Now we have to go and test this and verify this and so on. Okay. And yeah, that was, I presented these ideas at ETC, like mentioned, and it helped to kick off token engineering. And then also we published a white paper on this with where we said at the heart of it we have this objective, an objective function, just like an optimizer that we're trying to optimize, and we laid it out. In our case, it's a function of predicted popularity as a function of stake, and some other things too, basically. And before we did this, we'd done a similar analysis for Bitcoin itself. What's the objective function for Bitcoin, et cetera. And we had bonding curves in our design and so on. So we were pretty happy with that, and that's what we published on, and that's actually what we raised money on. And then also, yeah, we published these blog posts that Angela has referred to some of them, and I guess these are used a lot in Token Engineering Academy, so that makes me very happy. This was initially one long blog post, but then friends give me feedback, Trent, this is way too long, so you gotta chop it down. So I did. And then we also started having token engineering meetups. And I think Angela was even at the very first one, and I think by the 3rd meetup, Angela was running it, because I'm very happy, so thank you, Angela. And there was not just the meetups, but also these token engineering events that started to happen throughout the world, in New York and otherwise. So that was the pre-V1, right? And then we went to build V1, and we built it, and we raised the money and so on. And in V1, we raised money. Our ICO and IEO were in March of 2018. So about a year later, we shipped V1. And it had its own network. We actually had a POA network It had smart contracts for data access control. It had a DApp for data sharing, and it had upgradable contracts. But there was key things not shipped. We would have loved to ship this, but it would have, in fact, we had to descope in order to ship something at all, right? And we preferred to ship early, be a bit embarrassed by what we shipped, and then iterate. So things we didn't ship, right? Some of the core token mechanics from the white paper. We didn't have the bonding curves or that formula I showed a few slides ago. And this, to me was like a bit embarrassing, a bit painful, but so be it, right? Like you start with something knowing that you're going to get to that other stuff. We didn't have a data marketplace app. It was just data sharing, so we didn't have price data. So you can't have an economy if you don't have buying and selling of stuff, right? But it's a starting point. We didn't have a permissionless chain. We had our own POA, and in that case, we were using some special features of the parity client. And we didn't have immutable contracts. We had upgradability. At the time, we didn't actually understand how much of a trade-off it is. Once you have upgradability, it means that whoever's using your contracts has to trust you, the core team, right? And we actually have seen rug pulls from teams where they upgrade the contract and completely screw over their users. So this is a really useful thing to understand. We didn't understand this at the time, so we shipped with upgradability. Okay, but that was our V1. We learned, and we realized how uncomfortable we were when we shipped this. So, but for a V2, there was an even bigger thing that everyone was saying. They're like, I have this data. I don't want to share it directly. I want it where I want to keep my data private somehow. And we looked around at all these privacy-preserving approaches, homomorphic encryption, which has finally got mature, ZK, which has finally got mature, but it wasn't mature in 2019. It wasn't scalable, right? And other things too. And we realized there's something that doesn't show up at any of the cryptographic conferences that's really useful. Simply bring compute to the data. It's a DevOps problem, not a math problem. So that's what we did. We put it around a token infrastructure. And that was the heart of Ocean V2, something that we call Ocean Compute to Data. And it was a very practical thing. We put it in, and it's useful for privacy, but also for handling really heavy data that can't move, or legals, right? It's really hard to unlock data from a big enterprise. It'll take you 2 years of iterating with lawyers. So just keep the data inside and sell the results of the computation, right? So that was something we were quite proud of, quite a simple thing to explain too. To this day, it's probably the simplest thing to explain in Ocean. So even though we love to talk about token engineering and all this, to the average person, that's going over their head. But it's really easy for them to latch onto this idea. For privacy, compute to data, boom. So we often have to get past our academic selves, our engineering selves, and think about what is just simple for people to understand as sort of the tip of the spear. Okay, on to Ocean V3. So remember, in Ocean V1, we did a bunch of stuff that made us feel quite uncomfortable, right? And V2 didn't solve that stuff. It just solved another big problem, which was the privacy thing. But for V3, we had been thinking a lot, and we really wanted to meet the goals of the white paper. That was really our aim. And even before V3, we also realized, we needed to have actually a more system-level design that wasn't just about the bonding curves and curation. It was more about the ecosystem itself, everything around Ocean. And it took us about a year to come up with this design, but it's something that we call the Web3 sustainability loop. And it's also taught at TEA. And it's actually quite a general thing. And I'd done a couple startups before, blockchain land, and as a startup, right, you're raising money, you're going out there, you're using the money raised in order to grow the company and grow the value. And if you raise that money and take a vacation in Bahamas, then the value of the company go to zero and you can't raise money anymore, right? But if you actually do a good job with the money that you've been given, then you can actually raise the value of the company more than the money that you've taken in, right? And then you keep printing shares as a company to raise more money to grow. Go from a startup to a scale up, et cetera. Governments also have a similar pattern, interestingly, and with printing money, literally, and then using that to finance things. And if they allocate that capital inefficiently, then you have inflation, and we have this traditionally in places like Argentina, and now more and more in the West. But interestingly, this pattern also works well in token land, right? And it's this flywheel cycle, and we call it the Web3 sustainability loop. And in Ocean, it had some really cool benefits. So at the heart of it, this is it here. There's the workers doing the work in this loop here. But here, this we call the data ecosystem. And the main thing here is people can do work to build protocols, to build dApps, whatever here. But as far as the Ocean token is concerned, there's network revenue coming out, and a cut of, so there's revenue to others too, but a cut of whatever money flowing through, if you can get a cut of that going back to the community, where some of it goes back to growth with things like DAOs or incentives programs, and then also to sort of give this minimum baseline of value, you buy back and burn stuff. So basically, this is fueling growth, but you have some buy back and burn. And then you can just loop, loop, loop through that. And in the end, this will give you a positive feedback cycle, a snowball effect, right? And we actually, for this, I developed an agent-based simulator on my own in Python called Token Spice. At the time, it didn't have EVM yet. And we verified all this. And we found that certain parameters worked really well. For example, what percentage of burn should you have versus feedback to the community? And basically, you want to minimize this. You could put it to 0, but then the community doesn't get any baseline. So if you set it to 5% and the rest to 95%, then it will grow way faster and way better over time. It's the difference between 2x versus 10x in 10 years for growth. That's an example, and this is what the simulations showed us. And we also worked out many other things like what sort of token distribution should you have over time, et cetera. So it answered a lot of questions for us. But another key thing was we realized now we had tons of flexibility of whatever we put in there, right? So in terms of the driving value for the token, the name of the game was protocol revenue, right? And that actually really helped to give us flexibility as we developed Ocean V3. So then we did Ocean V3. And the heart of it was you can view it as a revamp of Ocean, core product. And it met the goals of the white paper, which for us was a great relief. So October 2020, about 2.5 years after we did our final ICO. But actually, we had to get past the sunk cost fallacy. We threw out about 90% of our code from V1, V2. That wasn't easy, because we had put our heart and soul into this. So we really had to get past that. But once we did, once again, the clouds parted, right? So, and we also, as we were doing this, what did we do specifically? Well, in our case, we saw, okay, we really want to kickstart this data economy. We want to have data wallets for custody and for management of data. We want to have exchanges, DEXs for data. We want to have DAOs where people can have data DAOs, a bunch of people doing collective bargaining, all this. So it felt like this huge mountain of work. But then we realized, you know what? People have already built, wallets for crypto stuff, tokens, ERC20, ERC721. They've already built DEXs for this. They've already built, DAOs, the Aragons and colonies of the world. So let's just leverage this infrastructure, this awesome stuff that has been built by the community over the preceding years. How? Tokenize it, right? So we simply tokenize data. And it feels so small and simple, so glib, right? Just like tokenize X. But it's actually a huge unlock, because now, as soon as you tokenize access control, we're at the heart of it, is if you have 1.0 data tokens, it's ERC20, if I hold 1.0 of those for a particular data asset X, then I can access the thing, okay? And now I can have a MetaMask or a Trezor hardware wallet, all that, to access the thing. And so very simple, but it unlocks all these things. It unlocks data wallets with custody, which is basically a replacement for SAP. It unlocks DEXs. So with V3, we also worked closely with Balancer, had automatic pricing with Balancer AMMs, right? Some teams emerged in the Ocean ecosystem doing data DAOs, leveraging the data tokens. And we also, the other things, about automatic pricing, this was a big goal always for us. The AMMs solved that. Permissionless, we just deployed to ETH mainnet. In the months that followed, we deployed to several other EVM chains too. Immutability, key thing. We went to non-upgradable contracts, right? And this for us was a huge relief, because we didn't want to have this monkey on our shoulders of liability, et cetera, as the foundation, right? So it was really nice not to have that. And there was one final thing, which is, in the white paper, we had the bonding curves, and it didn't have that directly, but we realized we could do something called data farming, which was sort of like liquidity mining, but optimizing for consume volume, and ship that soon. That was our hope, was soon. That also didn't happen. It took us about a year to get there because of what happened next. So what did happen next? So we shipped this thing, right? Tokenized data assets as ERC20 with DEXs, AMMs, Balancer, right? So here's live footage from the Ocean Core team post V3, right? We were a fire brigade for about 2 months, 3 months solid. Like, we were working 14-hour days nonstop for a while. It was exhilarating, by the way, like super fun, but also super stressful. Why? What was happening exactly? Well, people were publishing these data tokens, and then other people were speculating like crazy in them, trading and selling them. Several Telegram channels got set up specifically just to pump and dump data tokens and all this. And I was like, at first like, oh man, like this is not what we intended. We just wanted automatic pricing. But a friend of mine said, Trent, you know, like a prerequisite for establishing price of something is speculation. So I'm like, okay, well, I guess I can accept that. But even besides the speculation, other things happened too, which were clearly not so good. So the first one was fraudulent publishing. And we expected this. You know, I mentioned we were doing NFTs on Bitcoin in 2013, 2014. So we thought about this a lot, and we realized, you know, this is a problem that even, you know, Web 2 has, et cetera. And Web 2 has paths for this. The US government has something called DMCA takedowns, right? Where basically someone can come along and say, hey, you are using this copyrighted IP that I hold illegally, take it down, and you have to follow it, right? And there's similar things throughout the rest of the world as well. GitHub has actually a very, very cool policy around copyrighted information, sensitive data, and so on. So what did we do? Well, actually, I'll get to that in a second. So here are some examples. We got a letter, you know, very formal sounding, very formal letters from law firms. This one in Australia, you know, we represent so-and-so and its IP matters. As you're aware, we're a big technology company with lots of money. We want to sue you into oblivion, blah, blah, blah. And so-and-so has taken our data set and published it on Ocean Market, and that violates the terms of service, blah, 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 right? So we were wondering when this would happen, and it happened almost immediately. And we're like, oh, okay. So, but we were, you know, it's actually a very good practice in general. Don't anticipate everything up front and build for it all up front. When Bitcoin was first published, there was a bunch of holes in it, right? But, and even now, there's still some holes in Bitcoin that people have identified. But the Bitcoin community, to its great credit, would fix the holes as soon as they became real problems. So because we identified probably 20 possible problems, and there was a couple that really popped out. So one was fraudulent publishing, and our answer was basically copy and paste the GitHub approach around takedowns, et cetera. But it was a bit of a worry because we had this problem. Okay, we want to be permissionless, you know, smart contracts deployed to an L1, but we also want to follow the law. And here's the recipe. This is a really useful recipe in general. Actually, I'll talk about how the web works. So if you think about the web, I can take a server, I can run it in the middle of a random island in the middle of the Pacific Ocean. It can have an IP address, it can have a website, and anyone can access it, right? And no one can take that down, it's just there, right? But usually websites have a .com. It's like ENS, but going backwards, right, with the domain name system, DNS. And so if there's really bad stuff, you can just go to the DNS and have it taken down there. And websites themselves have policy. So the internet and the web is actually permissionless at the lower level. It just doesn't have state. That's the big difference between the internet and blockchain is state. And once you have state, then you can have smart contracts, all of this, right? But there's layers, so the very bottom layers are fully permissionless, and at the higher levels, there's different filtering along the way, right? Such that when you do a Google search or you go to certain websites, it has content that's acceptable. But of course, you can go to the dark web, et cetera, and it just exists. Same thing here. So on the L1, people can publish the stuff, you know, fraudulent stuff. We can't control it. We shouldn't be trying, right? But what we can do is we can control the top level, the DApp, Ocean Market. Other people can fork the Ocean Market DApp, have their own policies, et cetera. And this is what we did here. So it's a very useful trade-off between, yeah, permissionless and at the top level filtering. And we see this all the time too, like Uniswap, on the Uniswap contracts, they can't stop people from publishing, you know, scammy stuff. But the last mile, you know, they're mostly based in the USA. They have to follow the laws of the USA, so they do, right? So this is generally a very good heuristic. Okay, so we solved that. The next one, rug pulls. So what's the challenge here? Whenever someone published a data token, they owned, they would put this into a pool, and the pool was, they put 10% Ocean, say $10 worth of Ocean, and then it was 90% weighted towards the data token. So the overall pool had, say, $100 worth of Ocean, $10 worth of Ocean, sorry, yeah, $100 worth of assets, $10 worth of Ocean, $90 worth of the data token. But the data token side, you know, this publisher just published it. So they were the whale, right? They had all of it. So what started happening was people would publish, they would, some scam random data set, they would go into these channels, pump it up, and then dump, right? It was classic pump and dump, but it turned out to be extra easy in Ocean Market, like, oops. So, and here's an example. We started getting DMs like this. Hey, you know, I put 41 ocean, I'm getting feedback here. I put 41 ocean into my pool, and I went to take out the ocean, and I only have 15 ocean. And I'm like, okay, yeah, impermanent loss, you've got it. And it wasn't just that, though, like it was, but of course, like I said, the publishers were data token whales. So this, we realized pretty quickly, was a big problem, right? So we created on the left, this is a GitHub issue, an Epic and ZenHub, and we have like 15 different tactics to fix that, right? Boom, 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 boom. Some of them, purgatory for rug pullers. So once someone was unidentified as a rug puller, we would use the same policy of takedowns as for GitHub, and we would remove their assets and stuff, right? So that's one. We would raise awareness like crazy in blogs, et cetera. So we put out tweet and blog and all this saying, okay, be careful, understand what you're doing, et cetera, et cetera, et cetera. Another one, actually this made a big difference. Instead of this, you know, when you publish a pool where it's $10 worth of ocean, $90 worth of data token, flip it around, $70 worth of ocean, $30 worth of data token. So they would actually have to put a lot more liquidity up front. So that helped a lot, actually. And then finally, the community also stepped in. They started doing their own curation. There's something called the Data Whale Index. This guy Moritz in the ocean community basically put up a data set for sale, indexing all this. Another person in the community, Tim Delwinschutz, created something called rugpullindex.com, where he took a whole bunch of factors and automatically computed what's the chance of a rug pull. So this was really great stuff that the community stepped in too. And so this was sort of like the immune response towards rug pulls, right? But we realized there was still maybe a more definitive answer, and that led us down the path towards Ocean v4. Okay. So in Ocean v4, we're like, okay, we want to definitively solve rug pulls. So once again, we did the token engineering game. We wrote a bunch of different specs, constraints, and we went through a whole bunch of different designs. One-sided staking, liquidity, bootstrapping, it's an idea from the balancer community. Combining those two things, Dutch auctions with pools, vested pre-mines, more stuff, right? And we arrived at the thing on the far right after many things, after many iterations, and then we said, and we built it, right? And rug pools, so the general idea is people put their ocean stake in, and then the pool automatically mints the data tokens itself. So the publisher never ever has custody of the data tokens themselves. It's all sitting inside the pool. So we're pretty proud of that. And then through the token engineering community, through Trent, we took Token Spice and we extended it to work with EVM. So agents could now have EVM under the hood. And then we managed to replicate rug pulls with the Balancer v1 smart contracts in Ocean. And in this case, this is time, and this is agents' net worth in Ocean. And this basically, what's happening here, this malicious publisher publishes, they get a lot of Ocean, and then they rug pull, boom. And so they would get, in this case, 5,000 Ocean. So we managed to replicate this problem with simulations using Token Spice in EVM setting. And then we said, okay, let's put now in the one-sided staking contract, part of the v4 candidate design, see how it does. And it turned out it was 100x reduction. So they could do tiny little rug pulls, but you know, it's nothing in comparison. So basically that helped us to feel confident in the design. This was not a full verification though, this was just simulation. So there were still potentially edge cases, but we actually didn't have time to get to that. In retrospect, we should have made the time, because I'll show you what happened next. And this afternoon, I'm actually going to talk about how you can definitively verify this, but it requires more tools on top. But so this was, helped us to get a lot of confidence in the design, and actually helped us to tune it as well. And then we shipped Ocean v4. So we did use this one-sided staking strategy for the rug pulls. And then we'd gotten feedback for v3. Our ecosystem was saying, okay, we're running a market, but you've hard-coded where if you get a market, you only get 0.1% fee. But we want 2% fee. And we're like, yeah, people won't complain about 2% fees, so we gave them flexibility where if they're running a market, they could set the fee themselves. And also, we also have this compute to data, and we set it up where people could run their own compute to data nodes and charge for that. So they could be a third party running compute to data nodes for others. It's not in competition with full-on decentralized compute like iExec or Bacalhau or whatever. This is really for bringing compute next to the data itself, right? So it's a very unique special use case, but in practice, it's very, very important to have. And then also, yeah, obviously the community can make money publishing data. So we really wanted to help maximize the community's ability to make money by helping them set fees. So that was an important thing. This other question about governance attacks, right? So I already told you how for V3, we basically said no upgrading, right? And we hard-coded all the parameters, but the community was like, okay, you know, we want to set these fees. There's maybe other things. What do we do? And we also had new ideas about the data tokens, like, you know, what if you want to have a new ERC20 template? So what we did was we made it flexible where you can add more data token templates over time. So we started with 2, and we're about to ship a 3rd one now. And also, we gave some flexibility for some parameter settings. So it's really this trade-off of governance versus safety, right? And once again, you know how earlier I was saying how novelty is not your friend, novelty is risk? It's the same thing with governance. Governance is not your friend. You don't want to maximize governance, you want to minimize governance. And the optimal governance is zero governance. My favorite DAO in the world is called Bitcoin, because it has zero governance. Or you could equivalently call it a perfect democracy for electrons. That's it, right? So if you can get away with it, you should. Humans are squishy. We've seen all these DAO governance attacks over the last 1 year, 2 years, right? So in Ocean's case, we realized, well, we had this challenge. We wanted to have some flexibility, but not too much. And this was the optimal thing. So rather than saying, can't upgrade, can't change anything, versus, you know, full-on DAO, full-on everything, in between we said, okay, you can have new templates. You can twiddle a few parameters around fees for your market, but that's it, right? And that met our needs. And then also we introduced data NFTs to give a bit more flexibility there. Templates for those two. Okay. So that was Ocean V4. Post-release, what happened? So by the way, we no longer had rug pulls. All good, all good. But within a month of release, this was last summer, I was actually on vacation at the time, and we had this message coming from one of our community members. They informed us, we think there's an attack happening in Ocean. It's like one of these dreads that everyone in protocol land has, so it happened to us. It wasn't as well known, because Ocean isn't like a big L1 or something. And basically, they were staking Ocean in a data pool, buying data tokens, unstaking just the right amount. There was a very particular range of amount, and then selling the data tokens. And we looked at it, and we ran some calculations, and we realized if we raise the swap fee to 15%, it would make it too cost ineffective for them to do it. So that wasn't a big deal. We could do it for the near term. Wasn't a long-term fix, but that solved the problem, right? So we did that. We're like, yay, good, we solved, easy surgical, okay. Then, like a day later, I guess it didn't show up the attack too, but basically the same thing happened, but now the attacker just found new parameters and worked around it, right? And when we, and we didn't have the tooling in place to really verify this really well yet. Once again, the full-on analog token verification would have been awesome here. In this case, though, we saw like we can't just raise the fee to 20% or something. We really, like, the pools have a more fundamental flaw. And we saw that we could probably token engineer them to fix them, but we wouldn't be able to do that in a day or two. And we're like, so we've made this whole thing immutable, all this. What do we do about this? We racked our brains and we realized we still had flexibility on setting the swap fee. So we simply set the swap fee to 100%, and that made it impossible to make money on. It wasn't any long-term solution. It was, to be honest, pretty embarrassing to have there, right? I mean, that basically killed the usability of the pools. But at least no one was losing money. And that's really always the thing we come back to is like fundamental constraint. You know, don't let your community lose money, or if they do, let them make sure they know what they're doing, right? So here we saw the community was at great risk of losing money, so we set this, and basically it essentially froze the pools, right? And then after that, what we did in the time that followed, we made sure the whole community was made whole in terms of what they had for their funds in the pools. As well, we didn't have to do this. In general, actually, there's a lot of things you don't have to do as a protocol, but it's still the right thing to do. So we never make promises, but we basically say, okay, do we have the funds to help the community here, help them out? And in that particular case, we did. So we actually airdropped them for their losses too. So, so in general, you know, you're not on the hook for the thing, but you always try to do the right thing, and we found that that serves us well. And I think actually from even a legal perspective, you know, if you find yourself in a court of law 3 years from now or 7 years from now, this notion of reasonableness really counts for a lot. It's actually fundamental to business law, right? And there's this idea of no harm, no foul, right? So if people weren't hurt in the end, then it's not an issue. So we solved the problem in the near term, but then it's like, okay, how do we solve this medium term? And we basically racked our brains for 2 days intensively. We'd had ideas bubbling up before, and in the end, we actually basically ditched pools and instead replaced it with VE Ocean and curation on top of that. And there was another reason to ditch pools. Our community really wasn't getting the idea of impermanent loss. So that was a problem. They wanted a stake Ocean. We wanted curation. We wanted data farming. And our answer was a VE Ocean. So basically, we had, once again, went to the token engineering table, worked it all out, the different things. And I'll talk a bit more about VE Ocean later. But this was, once again, it was embarrassing. We had talked for like almost 2 years about pools and automatic pricing and staking, but we had to swallow our pride. We had to say, like the safety of our community was more important than that. And I find in my career that I can usually engineer my way out of almost anything. Give me some time to just do it. And a lot of the Ocean team is like this. We have this vibe in the team that we can just build it. And of course, there's not just the software. There's the human side, and there's always the human side. So we were always communicating with the community about this, laying out the facts as precisely as we could, and then giving the action. So if you give just a problem without any follow-up, people would be like, what's going on? But if you can be quick about it, you can lay the problem and the solution in the same blog post. So this is what we did, and we were very fast about this. And I'm very proud of the team that we handled it like this. Another thing, so we had shipped V4. And it's like traction was pretty good. You know, we've got some pretty cool stuff happening with Gaia X and with Daimler and bottom-up teams. And some projects coming. But at the same time, we had found ourselves, we did V1, V2, V3. V3, we met the goals of the white paper, awesome. V4 was really the tuning from V3 based on rug pulls, et cetera. But then it's like, what next? And the answer is, you don't need to be on the version treadmill, right? The thing is, when we deployed V3, it was whole new smart contracts, we had to migrate people. V4 also, it was partly new smart contracts, we had to migrate people. It's a huge effort just to migrate people. So instead we said, you know what? The system of Ocean is general enough. We can add more templates if we need. Let's really focus 100% on traction. Go to market, iterating with our users, learning from them, iterating. So we got away from the version treadmill. And instead, it's all about the use cases and all of that. And honestly, I wish we had done that sooner. But so be it. We had met the goals. How much time do I have? 3 minutes? Okay, I'll be quicker then. Great. Okay, awesome. Thank you. So I'll be very quick then. Token engineering around core product. Yes. So we did it, when we launched the initial Ocean token, it didn't quite have some mechanics for our vesting that we wanted. So we did a migration in August of 2020. Let our community know all of this. By the way, some scammers snuck in and tried to do stuff there. 1 month later, there was a KuCoin hack. 14% of the Ocean supply went into the hacker's hands. This was more than ETH had right before the DAO, the ETH hacker, or around for the DAO. So this hack happened, and we were up, and at first we're like, we're going to leave it alone. But then, to quote Mike Tyson, nothing like a punch in the face that changes your plans, something like that. So we decided to freeze the Ocean token, migrate again 1 month later, because this only happened a month after we migrated. And then basically the hackers' funds went away, right? And so it was a lot of soul searching. We really want decentralized, but we saw if that hacker sold that 14%, it could destroy the whole project, right? Just like Ethereum made its call in its early days as well. It wouldn't do the same thing now, but in its early days, in my view, it made sense. So we did that. We launched Ocean DAO Grants. In 2020, we ran it for 2 years. As it was coming along, I think we funded 200 teams or 200 projects over time. Very proud of the program. It was growing nicely. There were some people starting to game it. And then we realized the solution to that was retroactive, like Bitcoin, and even more objective, really great objective function. But then we realized that that was exactly what data farming was. And we saw that with Ocean DAO, it was going down this path of heavier governance and all this. So we decided, you know what? It was the same team working on Ocean DAO and data farming. We said, we're just simply going to wind down Ocean DAO. Data farming is basically DAO-like. It's the same goals, funding the community, but now a well-defined objective function. So that's what we did. Okay. And then, so we made Ocean DAO basically properly decentralized, the D in DAO, and automated by folding it into data farming. Also, this wasn't an easy decision, but I'm really glad we made it. And now we've doubled down on that. Once again, fully automated, right? Governance is something to minimize. And also the Ocean token itself. When we, even after the migrations, we had it where the core team was able to pause it, which never made me feel good, but we needed it in order to mint, for the minting. And finally, when data farming got far enough along, we could mint the rest of the remaining tokens. So we just did that about 3 months ago. And with that, we were able to remove all control from the core team of the token, and that was a huge monkey off our back. So I'm very happy about that. So now in Ocean, the only real decentralized thing left to decentralize is some of the data farming. So we're like 95% there. I'm very, very happy with that. And we've been pushing governance to the Leaf nodes. Okay, I know. So, and summary. So the Ocean model, yeah, we've got a blog post that just came out, so you can see that. And when you have a token, there's a lot of scammers, right? So you see all these things happening all the time. For example, there's people that register at oceanprotocol.ro and all these other things. So as soon as you hear about it, you do a takedown to the NIC. You just go to them, there's a policy there. We've proactively registered all the big ones like oceanprotocol.org, all of this. So that helps a lot. Also, how do you reconcile speculation with builder community channels? And a pattern that we use and many teams use is for the builder-oriented discussion, that's Discord. For the general discussion, but not speculation, that's controlled by the core team and our collaborators. And there's several speculator communities, especially a big one in Telegram, and that's a very useful heuristic. And let's see, keeping going. And yeah, what should you do first, product market fit or token? And ideally, if you have the funds, try to just build a thing, get it out there, and then layer in the token as you need. It's so much easier. Sometimes the token is really, really critical to the product itself, so then you kind of have to iterate. But product market fit, basically as soon as you can, go for it. There's a more nuanced view of this overall, and I've got a blog post from a couple years on that. And almost done, Angela. Great. Oh yeah, the conclusion. So that's it. I've shared the Ocean token journey for the core product, as well as everything in the ecosystem around, things like VE Ocean and all that. These are all like optimizes. But at the heart of it, because we follow this Web3 sustainability loop, we've had a lot of flexibility in what we can do where. And that allows us to basically go for traction, to drive the fundamental value, to grow the community, et cetera. And it's been a really fun journey so far. Ocean, I view, is now in a new phase because we've got past the white paper. It's all about traction. It's really fun. So thank you all for your time. Thank you, Angela, for your patience.
Thank you, Trent. I mean, you can see this passion on, 6 years in and managing all these struggles and this token journey. So thanks a lot for sharing, Trent, and being on stage today. And there is a recording, just in case you want to watch this talk again with such a rich content. Thank you so much. And while we are setting up the stage again for the next panel, I would be keen to hear your thoughts. I mean, we have heard about several of the main challenges for a token launch. Raise your hands. From your perspective, are you here because you think the regulation around tokens is the biggest challenge for crypto projects launching a token? No worries about regulation? Only 2. Okay, cool. And what about fundraising? Fundraising, biggest challenge for a token launch? Yeah, okay. Yeah, so. And what about the product market fit and the demand drivers? Okay, there's more. I mean, Trent actually built the stage for these topics. This journey, 4 versions of Ocean Protocol, many different iterations, or let's say the evolution of the mechanism design, of the token design of Ocean is really, just highlights some of the steps that have to be taken, and that a token design is basically something that is not done once you launch a token. It's a continuous evolution, and you have to react on your ecosystem, on your stakeholders, on the market, of course, and also on continuously growing the potential of your protocol. Good. Can we remove the state? Yeah. Okay. I'd like to now invite Marina, Dimi, and Robert on stage to discuss the top 10 challenges for a token launch. Give them a round of applause.